February 21st, 1943. The Tunisian desert stretches endlessly under a blazing sun, broken only by the jagged peaks surrounding Kasserine Pass. Through the shimmering heat haze, 5 American Sherman tanks advance across seemingly impossible terrain, ravines that should divide them, rocky outcrops that should blind them to each other's movements. Hauptmann Klaus Weber adjusts his binoculars from the commander's cupola of his Panzer IV. What he sees defies everything he learned at the Panzer Academy. The enemy tanks move with a precision that seems almost supernatural. No signal flags flutter in the desert wind. No dispatch riders race between the scattered vehicles. No flares arc through the dusty air. Yet somehow these Shermans coordinate like dancers in a rehearsed performance. The lead tank pauses, traverses its turret left, and immediately the trailing tanks respond, 2 swinging wide to the flanks, 2 others advancing to cover blind spots that the first tank cannot see. Weber has witnessed German armour execute such manoeuvres, but only after careful planning, detailed reconnaissance, and clear visual contact between commanders. These Americans are doing the impossible. Weber reaches for his radio handset, pressing the transmit button on his FUG 5 set. Static crackles through his headphones, punctuated by the rhythmic interference from his tank's engine. His 10-watt transmitter struggles to penetrate even 300 meters through the electrical noise generated by track movement and engine ignition. When he finally raises his company commander, the voice arrives as fragments dissolved in a sea of amplitude modulation interference. Contact. Americans. Cannot. The transmission dissolves into meaningless static. Meanwhile, across the battlefield, Staff Sergeant Joe Martinez speaks clearly into his throat microphone from inside. He is Sherman. His words travel on frequency-modulated radio waves that slice through the desert air with crystalline clarity. 25 watts of transmission power, generated by vacuum tubes cooled by forced air circulation, carry his voice to every American tank within an 8-mile radius. Able to all stations. Enemy armor, bearing 270, range 1,200 yards. Suggest we execute flanking movement, Charlie. The response comes immediately, voices crisp and unmistakable despite the roar of engines and the grinding of steel tracks on stone. Roger, able to. Baker section moving to support. Another voice joins. Charlie section in position to provide overwatch. No confusion, no repetition, no static. Weber watches in growing disbelief as the American tanks execute their maneuver with mechanical precision. Each crew seems to know exactly where their comrades are positioned, exactly what threats they face, exactly how to respond. It's as if some invisible force connects these scattered vehicles, allowing them to fight not as 5 individual tanks, but as a single thinking organism. What Weber cannot know, what no German commander yet understands, is that he's witnessing the future of warfare itself. This moment of American superiority would have seemed impossible just a decade earlier. In the 1930s, Germany led the world in military radio communications. General Heinz Guderian, the architect of Blitzkrieg doctrine, had insisted on radio equipment for every tank since the 1920s. His revolutionary book, Achtung Panzer, proclaimed that rapid armoured advances depended entirely on instantaneous communication between commanders and their subordinates. Guderian understood something that most military leaders missed. Tanks without radios were just expensive artillery pieces. The German Wehrmacht had embraced this philosophy completely. During the early war years, German panzer divisions swept across Europe using radio coordination that their enemies couldn't match. Polish cavalry charged German tanks that could call for air support within minutes. French armour, magnificent in individual combat, fell to coordinated German attacks directed by radio-equipped commanders. But by 1943, the nation that pioneered tank radio warfare was drowning in the contradictions of its own success. The numbers tell a stark story. German industry produced approximately 5,700 medium tanks during 1943, but fewer than 2,000 Fuji 5 transceivers. The mathematics were brutal. Most German tanks entered combat without the radio equipment that Guderian's own doctrine demanded as essential. The reasons stretched across the entire German war economy. Copper for wiring was desperately needed for ammunition production. Vacuum tubes required rare earth elements that the Reich could no longer import. Skilled electronics technicians were drafted into combat units faster than factories could train replacements. Every radio that went to a tank was one less available for aircraft, artillery, or infantry units. German tank crews are targeted, apted with typical ingenuity, developing elaborate hand signals and light codes. But these solutions worked only when tanks could see each other, a luxury rarely available in the smoke and chaos of modern combat. More critically, they created a fatal vulnerability that German commanders didn't fully recognize. When command tanks were destroyed, entire platoons lost their ability to coordinate. The few G5 radios that did reach frontline units carried their own limitations. Operating on amplitude modulation in the 27 to 33 MHz range, they generated interference from every electrical component in the tank. Spark plugs firing, motors running, tracks grinding against drive sprockets, all of it created static that overwhelmed the already weak 10-watt transmission power. By the time Hauptmann Weber peered through his binoculars at those impossibly coordinated American tanks, Germany's radio superiority had become Germany's radio poverty. The nation that taught the world about electronic warfare was about to learn a harsh lesson about American industrial innovation. 3,000 miles from the Tunisian desert, in a nondescript factory building on Chicago's northwest side, engineers Daniel Noble and Henrik Magnoski were solving problems that German industry couldn't even recognize. The Galvin Manufacturing Company, soon to be renamed Motorola, hummed with activity 24 hours a day. Assembly lines that once produced car radios for weekend drivers now manufactured the most sophisticated military electronics on Earth. Noble, a soft-spoken engineer with thick glasses and ink-stained fingers, had spent years perfecting something called frequency modulation. While German engineers struggled with amplitude modulation's inherent limitations, Noble explored an entirely different approach to radio transmission. Instead of varying signal strength, FM varied signal frequency. The difference seemed academic until you heard it in practice. Where AM radios picked up every electrical discharge as crackling noise, FM radios delivered conversation-quality audio even during thunderstorms. Engine noise that obliterated AM transmissions barely registered on FM receivers. The mathematical elegance was matched by practical superiority that would prove decisive in combat conditions. Magnoski faced different challenges. How do you install delicate electronics in a machine designed to absorb enemy fire? How do you keep vacuum tubes functioning when tanks cross ditches at 20 miles per hour? How do you provide stable electrical power when the tank's generator produces wildly fluctuating voltage? His solution weighed 181 pounds, the SCR 508 radio set. The transmitter alone contained 474 capacitors and 385 resistors, all manufactured to tolerances measured in thousandths of an inch. Crystal oscillators maintained frequency stability despite temperature swings from Sahara heat to Russian winter. Shock mountings protected sensitive components from combat vibration that could shake fillings loose from a man's teeth. The engineering specifications read like science fiction to anyone familiar with existing military radios. 25 watts of transmission power, 2.5 times German output. Crystal-controlled frequency stability accurate to within 0.01%. 10 preset channels that could be changed instantly without retuning. Dual receivers that allowed commanders to monitor multiple frequencies simultaneously. But the real revolution lay in deployment philosophy. While other nations installed radios only in command vehicles, America equipped every single tank. The industrial statistics boggle the mind. By war's end, American factories would produce over 50,000 tank radio sets. This wasn't just mass production, It was precision mass production of equipment more sophisticated than anything in German laboratories. Each SCR 508 required 2,748 individual components manufactured to exacting specifications. Quality control inspectors tested every unit in temperature chambers, vibration tables, and electrical interference simulators that replicated combat conditions. Units that passed inspection were sealed in waterproof containers and shipped to tank depots across the United States, where they were installed in every Sherman that rolled off assembly lines. The contrast with German production was devastating. While Wehrmacht units fought over scarce radio equipment, American tank crews trained with radios as standard equipment. While German commanders developed tactics around communication limitations, American doctrine assumed universal radio coverage. By the time the first SCR 508 equipped Sherman entered combat, the United States had already won a war that most people didn't know was being fought. November 8, 1942. Operation Torch brought American armor to North African shores with an electronic advantage that would take months to reveal itself fully. The 2nd Armored Division's Shermans splashed through Mediterranean surf onto Moroccan beaches, their radio compartments sealed against salt spray, their crews already practicing communication procedures that German intelligence would struggle to understand. The Afrika Korps represented Germany's most experienced armoured formation. Erwin Rommel's desert veterans had perfected tank warfare against British forces that often fought without adequate radio coordination. German tactics had evolved to exploit enemy communication weaknesses, attacking during radio silent periods, jamming known frequencies, targeting visible command antennas. These techniques would prove useless against an enemy where every tank was a command tank. Lieutenant Colonel John Waters, commanding a Sherman company during the advance on Casablanca, experienced the difference immediately. His radio crackled with clear reports from subordinate tank commanders. Contact, bearing northeast, range 800 yards. Enemy infantry spotted in buildings ahead. Request artillery support, coordinates follow. Each transmission arrived with clarity that would have impressed telephone operators back in Detroit. No static interference, no garbled messages requiring repetition, no communication blackouts when tanks moved into defilade positions. Waters could coordinate his entire company while monitoring higher headquarters frequencies, maintaining what military theorists call situational awareness, but what tankers simply call staying alive. The contrast became apparent during early skirmishes with Vichy French forces. American tank crews who had never seen combat executed coordinated movements that veteran German observers at Ptars attributed to extensive training. French defenders, equipped with obsolete radios when they had any at all, found themselves facing an enemy that seemed to possess supernatural coordination. But the real test came in February, when Rommel launched Operation Spring Breeze against inexperienced American forces at Kasserine Pass. The tactical defeat that followed has been analyzed exhaustively by military historians, but most miss the electronic dimension of the battle. German forces achieved initial success through superior tactics, training, and equipment. American units retreated in confusion, leaving behind hundreds of destroyed vehicles and thousands of prisoners. Yet even in defeat, American radio coordination impressed German intelligence officers enough to generate classified reports that would influence Wehrmacht thinking for the remainder of the war. A captured intelligence summary noted, American tank units demonstrate exceptional radio discipline. Communication remains clear and coordinated even during retreat operations. Units separated by terrain obstacles maintain contact at ranges where German equipment produces only static interference. This coordination appears to result from standardized procedures rather than individual initiative. The analysis was both correct and incomplete. American crews did follow standardized procedures, but those procedures were built around technological capabilities that German forces simply didn't possess. When scattered American tanks regrouped 50 miles from initial positions, they did so through radio coordination that would have been impossible with German equipment. Rommel himself reportedly commented on American flexibility in maintaining communication during fluid operations. He attributed this to American training methods, not recognizing the electronic revolution that was reshaping armored warfare, the guerre d'artet. Mans were fighting the previous war's battles. Americans were pioneering the next war's methods. The invasion of Italy revealed just how decisive radio superiority could become in terrain that seemed to favor defenders. Sicily's rocky hills and Italy's Apennine valleys created natural radio shadows where conventional wisdom said communication would be impossible. German defenders positioned themselves in locations chosen specifically to disrupt enemy coordination, reverse slopes, deep valleys, anywhere that line-of-sight communication couldn't reach. The Americans advanced anyway, their FM radios slicing through multipath interference that rendered German AM systems useless. In mountain warfare, radio waves bounce off cliff faces and canyon walls, creating multiple signal paths that arrive at receivers at slightly different times. Amplitude modulation couldn't handle this complexity. The signals arrived as unintelligible noise. Frequency modulation processed these multiple signals cleanly, delivering clear communication even in the worst terrain. Tank Commander Staff Sergeant Mike Kowalski discovered this advantage during the advance on Monte Battaglia. His Sherman sat in a valley completely blocked from visual contact with supporting units positioned on surrounding ridgelines. With German equipment, he would have been isolated, fighting blind. Instead, his SCR-508 maintained crystal-clear contact with tanks he couldn't see, artillery observers he couldn't reach, and air support controllers coordinating from miles away. The coordination proved lethal to German defenders who had positioned themselves to exploit communication difficulties. American tanks appeared where German doctrine said coordination should be impossible. Artillery strikes arrived with precision that suggested forward observers in positions where no visual contact existed. The invisible network was winning battles before German commanders understood they were fighting it. But Normandy brought new challenges that tested American ingenuity. The bocage country of northwestern France featured dense hedgerows that created natural tank traps. Worse, it revealed a critical gap in American communication systems. Tank radios couldn't talk to infantry radios. The SCR-508 operated on 20 to 28 MHz, while infantry SCR-300 sets used 40 to 48 MHz frequencies. The two systems were incompatible. This gap proved deadly in hedgerow fighting where German infantry armed with Panzerfausts could approach American tanks, while nearby American infantry had no way to warn the tank crews. Several Sherman commanders were killed in situations where infantry support was available, but coordination was impossible. American field innovation solved the problem within weeks. Tank crews began mounting EE-8 field telephones in external ammunition boxes, wired directly to the tank's intercom system. Infantry soldiers could approach the tank, lift the phone, and speak directly to the crew inside. It was crude but effective, and it demonstrated the adaptability that radio coordination made possible. By Operation Cobra in late July 1944, American tanks were coordinating not just with each other, but with infantry, artillery, air support, and naval gunfire. The network had become a web that connected every American unit on the battlefield into a single, responsive organism. July 25, 1944. Operation Cobra unleashed the full potential of networked warfare on an enemy that still fought as individual units. From his command post overlooking the Saint-Vith breakthrough, Major General Edward Brooks coordinated over 200 Sherman tanks through radio networks that enabled battlefield control on a scale never before attempted. The contrast with German capabilities was stark and fatal. The elite Panzer Lehr Division, Germany's showcase armoured formation, faced an enemy that seemed to possess omniscient awareness of battlefield conditions. American tanks responded instantly to threats reported by units miles away. Artillery strikes coordinated through tank radios arrived within minutes of target identification. Tank destroyers received targeting information from Sherman commanders who couldn't see them, but could guide them onto targets with mathematical precision. Oberst Fritz Bayerlein, commanding Panzer Lehr, watched his division disintegrate under coordinated attacks that his training said should be impossible. German tactics assumed that scattered enemy units would fight as individuals, allowing concentrated German forces to defeat them piecemeal. Instead, American units fought as a connected whole, each tank serving as eyes and ears for every other American unit in radio range. The electronic dimension of the battle reveals itself in after-action reports that German commanders filed with growing desperation. Enemy coordination suggests extensive preparation and rehearsal, one report noted. Tank units separated by terrain obstacles maintain tactical cooperation at ranges where visual contact is impossible. Another observed, American artillery response times indicate communication capabilities superior to our own systems. These reports consistently attributed American performance to training and planning, rather than recognizing the technological revolution they were witnessing. German intelligence officers, working with incomplete information and preconceived notions about American capabilities, couldn't conceive that every enemy tank carried communication equipment superior to their finest command vehicles. Sergeant First Class Tommy Rodriguez, commanding a Sherman in the Spearhead Advance, experienced the battle from inside this invisible network. His radio crackled with constant updates. Panzer Mark IV, bearing 090, range 600 yards. Panzerfaust team in hedgerow ahead. Artillery mission complete, all stations clear to advance. Each transmission arrived with clarity that made coordination automatic. Rodriguez could position his tank to support units he couldn't see, receive warnings about threats he hadn't detected, and call for support that arrived exactly where needed. His individual tank had become part of a larger intelligence that processed information faster than any human commander could manage alone. The mathematical results spoke for themselves. Over 3 weeks of fighting, the 2nd Armoured Division destroyed 281 German armoured vehicles, while losing only 41 Shermans, a 7-to-1 kill ratio that defied the technical specifications of the equipment involved. German Panthers and Tiger tanks possessed superior armour and firepower, but they fought as individuals against an enemy that fought as a coordinated network. The invisible advantage had become a decisive advantage. Information dominance was proving more lethal than platform superiority. In the electromagnetic spectrum, America had achieved supremacy that German industry couldn't match and German doctrine couldn't counter. March 7, 1945. When elements of the 9th Armoured Division discovered the Ludendorff Bridge at Remagen still standing, radio reports reached 1st Army headquarters within minutes. The speed of American command and control had reached its zenith. Entire divisions began shifting to exploit the opportunity before German defenders could react effectively. The contrast with German capabilities was complete. Wehrmacht units, dependent on telephone lines that Allied aircraft systematically destroyed, couldn't respond with comparable speed to rapidly changing situations. Radio communication had collapsed across much of the German front, leaving isolated units fighting individual battles without coordination or support. Lieutenant Colonel Leonard Engerman, commanding the task force that seized the bridge, coordinated his advance through radio networks that connected his tanks to artillery, air support, and higher headquarters simultaneously. When German counterattacks developed, American response arrived with mechanical precision. Tank platoons from different battalions integrated seamlessly, their radio compatibility eliminating the confusion that usually plagued mixed-unit operations. German forces attempting to recapture the bridge found themselves fighting an enemy that seemed to anticipate their every move. American tanks positioned themselves to cover approaches they couldn't see, guided by radio reports from observation posts miles away. Artillery strikes arrived within minutes of German movement, directed by forward observers who could coordinate with tank commanders in real time. The encirclement of the Ruhr pocket demonstrated American communication superiority on an operational scale. 1st and 9th Army columns coordinated a complex double envelopment entirely through radio communications, maintaining precision timing across hundreds of milliseconds of front. Inside the pocket, 325,000 German troops found themselves trapped partly because their communications had collapsed completely. Field Marshal Walter Model's final messages before communication failure revealed the German predicament. No contact with adjacent units, no communication with higher headquarters. Fighting continues, but coordination impossible. The most experienced German field commander was describing the reality that had dominated German operations since Normandy: isolation in an increasingly connected war. American fighter bombers, guided by radio-equipped forward air controllers, systematically destroyed German communication nodes throughout the pocket. Wehrmacht units lost contact not only with higher headquarters, but with each other, fighting desperate individual actions within a larger battle they couldn't comprehend or influence. When Model surrendered the remnants of Army Group B on April 18th, he reportedly commented to his American captors, "We knew how to build better tanks, but you knew how to make them work together." Whether accurately quoted or not, the observation captured a fundamental truth about the war's electronic dimension. The SCR-508 radio that connected Sherman tank crews across 3 continents established principles that govern warfare today. Modern main battle tanks carry digital communication suites that trace their lineage directly to those vacuum tube pioneers, different in technology but identical in concept: universal deployment, reliable coordination, information dominance over platform superiority. The German Bundeswehr, rebuilt in the 1950s, learned the lesson completely. Every Leopard tank manufactured carries comprehensive radio systems. Bundeswehr training manuals explicitly state that the defeat of superior German tanks by inferior American vehicles with superior radios teaches that information dominance outweighs platform superiority. Modern conflicts validate this lesson repeatedly. In the 1991 Gulf War, coalition forces with superior communications destroyed Iraqi forces equipped with individually superior Soviet-designed tanks but inferior coordination capabilities. In 2003, American forces again demonstrated that network-centric warfare defeats platform-centric warfare. The story of Sherman tank radio superiority represents victory in the electromagnetic spectrum that proved more decisive than advantages in armor or firepower. German tank crews fought partially blind to this revolution, discovering too late that every Sherman was not just a fighting vehicle, but a node in history's first battlefield network. Today, as we witness the evolution toward artificial intelligence and autonomous systems, the lesson endures. The side that shares information faster, coordinates more effectively, and fights as a connected force will defeat the side that fights as individuals, regardless of individual platform superiority. In the end, those 181 pounds of radio equipment carried by every Sherman tank changed warfare forever. The invisible electromagnetic waves that connected American tank crews proved more powerful than the thickest armor or largest guns. Connection had defeated isolation. The network had defeated the platform. And in the silent frequencies that still hum across battlefields today, the victory achieved by those radio-equipped tankers continues to echo across the spectrum of modern warfare.